Hi, this is Tony Northrup for Train Signal, and in this video lesson for the SSCP certification exam, I'm going to discuss security assessment activities. Now, a security assessment is just a way to size up how secure or not secure your organization is. So you kind of scan the whole organization and you find weaknesses and vulnerabilities and things that need to be patched. Some people will call it a security review or a security audit. It's also really important to do this for regulatory compliance if you happen to be in an organization that has government regulations that apply to it. Now, the first time you do a security assessment, you're going to be creating a baseline. You're going to be finding all the things that are right and wrong with the organization and making a big list. And then you just have to make modifications to that. Every time you do it in the future, you'll just be seeing what's changed against the baseline. So you'll be able to detect new services that were added that maybe you didn't know about, new vulnerabilities that cropped up, or maybe things that were correctly fixed later. It's really important to always do a security assessment with permission. I'm going to show you some tools that will allow you to do security assessments, and it will just ask you for a range of IP addresses. And you could put in any organization's IP addresses, at least technically, but please don't do that because it's illegal. You must only test networks that you have explicit permission from the owner to test. Now, there's no one universally accepted security assessment process, but here's one that I kind of made up. It goes through 6 various stages, and you'll see that all the different processes follow the same basic steps. They just kind of group them differently, or they gloss over some things and not others. Of course, your first step is to meet with everybody. That's the project initiation. Then you start to kind of poke around and see what assets are available, and that's the information discovery process. We're going to go into all these in more detail in the later slides. And the third step is risk identification, where you size up the threats out there. Step number 4 is the vulnerability scan, where you actually detect weaknesses in your existing systems. Step 5 is data analysis, and that's where you take a look at all the data that you've collected so far. And finally, you tell everybody about it. That's step 6, reporting and briefing. During the project initiation, well, it's a meeting, though you'll probably precede it with various emails and other types of messages. You identify the stakeholders, and the word stakeholder just means anybody who has a say in a particular resource or asset in your organization. So it's going to be managers and network administrators. If you have special systems for the accounting department, well, the accounting manager probably wants to be there. So you figure out who all these managers are, and that usually involves contacting the higher-ups in the organization and having them delegate the responsibility down to the lower people. So you will talk to basically the highest level manager that you have access to, and maybe that's the CEO, or maybe it's somebody beneath them. And then they will go out and reach out to the different department heads, and maybe those department heads will say, hey, okay, I'm going to handle this myself, I'll show up to the meetings. Or maybe they'll say, I'm going to delegate this down to a couple of my different managers who I think this will be important to. That sounds a lot easier than it is. In the real world, this ends up being a real political thing, and you'll have people being like, why wasn't I invited to this meeting? I'm important too. And then you'll have people like, I don't have time for this meeting, and they say they're going to be there and then they just won't show up. So identifying the stakeholders, you'd be surprised, that's a pretty challenging part of this overall process. And then you have to actually meet with them, and you tell them what you're going to do. You ask them what the most important things to check out are, which assets they think are the most valuable. And you'll also ask them what risks they already know about. The stakeholders already know a lot of the stuff that you need to figure out. They know about some risks and vulnerabilities, so just ask them and they'll tell you. And you can explain that they don't need to know everything. Nobody expects them to do that. You're going to have your own discovery process where you'll find things that they forget about, but it's really important to get whatever information from them you can. And you'll take this information that you gather and you'll create a statement of work. And in any project, the statement of work is just a long list of what you're going to do. It's a commitment. It's saying, I am going to scan the networks and do my best to identify important assets, risks, and vulnerabilities. I'm going to use these types of techniques to scan for them. You don't need to speak in absolutes. You don't need to say, I'm going to find every vulnerability, and when I'm done, the network is going to be completely 100% secure. Don't do that. Tell them what you're actually going to do. And be specific. Tell them the specific tools that you plan to use to scan, because when it's all done, you're going to miss something. Nobody's perfect, right? It's your statement of work that will protect you, because you can say, hey, I did what I told you I was going to do. If you wanted me to scan that network too, if you wanted me to use this extra tool, you should have said. I would have done it. Step 2, the information discovery. Now, this is the most boring stage that you're going to find. Here you're going to be going through existing documentation. You're going to be looking through all the security guidelines that the security department has already put together. You're going to be looking at the regulatory requirements that apply to your organization and figuring out exactly what you need to make sure is in place. You're going to be looking at existing inventories that they have of every computer, every system, every piece of software that's running. And you're going to be looking at network design, showing how the firewalls and the networking equipment and the different servers are connected and protected. You're going to use all this information to figure out what to scan and to identify risks, vulnerabilities, and assets that you need to protect. And step 3 is risk identification. And I've gone into more detail on this in other lessons, so I'm not going to go over the whole risk assessment process now. But basically you identify the assets. This can be computer systems and networks if you're in IT, but it often also includes physical assets like facilities and buildings. Filing cabinets full of paper, that's data too, right? And the threats against them, people breaking into buildings, hackers, malware, corporate spies, foreign governments if you're in the military. Once you know how valuable an asset is, what the risk of a threat successfully compromising your systems are, and how much damage that threat can do to your asset, you just calculate risks. In the best case scenario, this is all done quantitatively, and you have monetary values for everything, and you just plug it all into a formula and you figure out the exact monetary risk for every threat out there. More often, it's qualitative, and you kind of say, oh, this risk is really dangerous, this is critical, and this is not as dangerous. And you'll use these priorities to kind of channel your efforts later on. And in the final stages, as you're reporting, you'll be able to identify which vulnerabilities that you discovered are really the scariest. Because, of course, a vulnerability that impacts a really valuable asset is a lot scarier than a vulnerability that impacts something you don't care that much about. Step 4 is the most fun part of this whole process. It's certainly better than those meetings, right? This is the vulnerability scan. You get to fire up all sorts of tools and scan both your internal and external networks. Sometimes this scanning involves taking a physical inventory, going to data centers, making sure every system you physically see is accounted for and being scanned properly. Sometimes you even get to do penetration testing, which is terribly fun. You get to put on a white hat, but you act like a black hat hacker and you try to break into your own systems with permission. You get your hands a little dirty and find all these sneaky tools that they have out there for cracking into systems. And you know what? If you can break into your own systems without using any of your inside knowledge, well, you've discovered some vulnerabilities that need to be patched because somebody from the outside could do the same thing. You need to test both your internal and external applications, but especially those internal apps, because more than likely, if it's coming from a big software vendor like Microsoft or Oracle, then it's been tested pretty thoroughly already. Doesn't hurt to give it your own go, but you should put most of your energy into your own internal apps. And that's not just scanning them, but that can also mean reviewing code. Of course, you need to be a knowledgeable developer to know how to do this, but I especially like to spot check code and just make sure everybody's following security best practices. You might not have time to look at every single line of code, who would? But if you do a spot check, often you can find an app that has real problems and call it out pretty quickly. Vulnerability scans often involve scanning for wireless networks, Wi-Fi networks, because sometimes users will just plug in their own wireless access point. You know why? Because maybe they don't have access to the corporate Wi-Fi, or maybe they think it's not fast enough, or the wireless access point is too far away. But what happens then is, well, they don't protect it properly, and then somebody sitting in the parking lot can hop on their rogue Wi-Fi network and access your internal networks through that. And that's a pretty scary thing because you lose some level of access control over your network. So you'll go there with, sometimes it's just your smartphone, or sometimes or you might use a specialized device for finding these Wi-Fi networks, and you'll track it down based on the signal strength. It's just like something out of a movie. And then when you find that Wi-Fi network, oh, you talk to whoever set it up and maybe give them a slap on the wrist. And finally, you also need to get permission from any hosting providers that you use so you can scan at least the part of the network that you're leasing from them, whether it's web hosting or some sort of cloud services. Of course, you can't just go scanning their networks. That's their property, and you need permission for everything you do. But it is really important that you include any sort of hosted services in your vulnerability scan. Step 5 is also fun if you're an analytical geek like me, but you get to go over all that data that you collected during the vulnerability scans, and you separate the real vulnerabilities from the false alarms. And I'll tell you what, there's going to be a lot of false alarms. You look at these reports and they'll be like, oh no, server 123 is listening for net buoy connections. But you go and look into it further and you realize, oh, it needs to listen for net buoy connections because it's sharing files. It's just a requirement of it. So it's not, well, it is a real vulnerability, but it's a risk that people have already decided to accept. Or maybe it's being mitigated by an external firewall and the connections are extremely limited, or maybe they're IPsec protected. You don't know. But you will run across a lot of false alarms. In fact, I would bet 95% of the vulnerabilities that your scanning software finds are going to be dismissed as false alarms. The number might even be higher. As part of the data analysis, you'll put together architecture diagrams showing how everything is connected. This is important to understand because different network components impact each other's security. Of course, if an attacker manages to compromise a router, well, they could use that router to send traffic to other networks, to do IP spoofing, things like that. Firewalls might mitigate certain vulnerabilities for hosts on the internal network. So it's really important that you understand the architecture. Hopefully some of that exists already, but you know what? There are a lot of organizations out there that don't have a model for their systems, and a vulnerability scan is a good time to put that together for them if they don't have it yet. All this adds up to you determining the attack surface. These are potential places where your organization can be attacked, and it's going to be hosts and apps and protocol and data and your email and DNS infrastructure. It's going to be physical security, things like doors that aren't guarded and an employee smoking spot where they just leave the door jammed open in case they forget their key card. That kind of thing happens. Phone services, any place an attacker might enter your organization, including through a phone call, is something that you need to indicate as part of the attack surface. And nowadays, everybody's got a mobile phone strapped to their hip, and this is a security risk that you need to note and be aware of, even though for most organizations it's not something you can really get rid of. Now I'm going to demonstrate a network vulnerability scanning tool called Nessus. So we'll get to check out my own home network. So I've taken the liberty of setting up a Nessus vulnerability scan for my home network, and I downloaded the software, which is free for an evaluation or for home use. I ran the scan, and as they say on Seinfeld, yada, 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 here's the results. So you can see in the host tab here, the Nessus scanning found 11 different computers or other devices, anything responding to an IP address. So this is going to include my wireless access points and routers, and oh my God, I have 11 devices at my house. I think my stereo is connected to the network. So what this tab is going to tell you is every device that's listening or responding to any sort of incoming connection. It doesn't necessarily tell you about every host because there are hosts that are completely silent on the network. These hosts remain hidden and simply can't be detected using this type of scanner. Hopefully none of these devices are a surprise to you, but in most organizations you're going to find computers using IP addresses that you simply didn't know about. One way to reconcile the devices based on their IP addresses is to look at your DHCP server. The DHCP server is the server that assigns the IP addresses to all the computers on the network, assuming you use automatic addressing. You'll be able to look at this list and it'll tell you the MAC address, maybe it'll even tell you the host name. The Nessus tool will ferret out some information that can give you a clue as to the identity of the host, but your own inventory systems are going to be a lot more reliable. And of course, your DHCP server won't have information about computers that don't receive automatic IP addressing. Typically, routers and DHCP servers don't, so there will always be some devices that won't have DHCP assigned addresses. So I know this address to be my router. Let's click on it and dig in a little bit. Okay, so this is actually a legit concern. You can see that it marked a high vulnerability here. This router is listening to SNMP requests. SNMP is a simple network monitoring protocol, and it's this incredibly outdated protocol that just accepts a community name as authentication. And it also tends to use default community names. You can see I haven't assigned a non-default SNMP name. And in fact, I don't have SNMP monitoring for this particular router, so I know that I should simply turn off SNMP monitoring. It only listens to requests on the internal network. However, if somebody managed to gain access to my internal network, they might be able to use that to change the configuration of my router. And once they can change the configuration of my router, well, they could do a lot of terrible things in my network, like man-in-the-middle attacks. Now, this is marked as a low priority DHCP server detected. That means that Nessus found a service that's assigning IP addresses. DHCP is the Dynamic Host Configuration Protocol, automatic IP addressing. And my router should be running a DHCP server. So this is a false alarm because I know this computer should be running DHCP. DHCP can be a threat in a network, though. If I were an attacker, I could hook up a DHCP server to a network and start giving out bad addresses to hosts. If I assign a host's IP addresses, well, I can configure it to use me as its DNS server. And then when that guy goes to visit his bank's website, I'll send him the IP address of my malicious host instead of his actual bank, and I can complete a man-in-the-middle attack. For that reason, rogue DHCP servers can be a real risk, and you need to make sure that every DHCP server on your network is trusted and accounted for. Now you can see quite a bit of other information here. These are marked as info, but let's take a look at a couple of them. You can see it found a web server here, so I'll click on this, and this basically just tells me that the router is listening for web requests. And I know this because you can use a browser to configure the router. That's pretty standard for these type of consumer-based routers. So this is a known risk. It has an HTTP server, that's a risk, but I can accept that risk. Let's take a look at the Ethernet card manufacturer detection. All network adapters have what's called a MAC address, media access control address. And the way these MAC addresses are assigned is some governing body hands out a range of addresses to a network adapter manufacturer. And these are publicly registered. So when you look at a MAC address, you can identify the manufacturer. And you can see here the manufacturer of this MAC address is Syswan Technologies. That is, unless somebody modified the MAC address, which is technically possible and certainly feasible in the event of a malicious host. This is just a bit of inventory information that you can use to help you identify a computer. Let's see what it found for the OS identification. Okay, so it did a pretty good job of identifying the operating system. It identified it as a Nortel switch. Nessus is pretty smart, and it'll kind of poke the computer and send it different types of requests, and then look for signatures that indicate the operating system that it's running. Now, it can't detect every possible operating system, but I found that it's pretty reliable. Now let's go back to the host, and I'll check out this computer. I know this to be a really old web server that I have running, and I have it pretty well hidden from the public internet, but it's not that well hidden on my own internal network. And we can see that it's found quite a few different potential security risks. This top one up here is legit. Microsoft.NET custom errors not set. This web server is running an ASP.NET based website. That's a web development platform that I'm pretty well versed in. And I do not have custom errors set on the internal network. And what that means is it provides useful error information to me in the event that I need to troubleshoot it in case there's a web development problem. So why does it consider that a security risk? Well, useful error messages are useful to attackers as well. For example, if I add a bug to the code, the error message would show me a snippet of the source code and show me exactly where the code crashed. That's helpful for me troubleshooting. An attacker could look at the code and gain some piece of information that might help him attack it. You can see that tracing is enabled on the internal network only, which would give a potential attacker more information about how the application was running and potentially improve their ability to hack my system. You can see other low-level potential risks and vulnerabilities, probably due to the fact that this is running an old operating system. Let's see if it could figure out exactly which operating system it is running. So much information about this. There we go. OS identification. Oh, it got it. Microsoft Windows Server 2003 Service Pack 2. Yes. Look, if it ain't broke, don't fix it, right? I know it's an old operating system, and they put the year it was made right in the name just to make sure you know it's old. but it keeps running well. One other thing I want to look at, Rdp Screenshot here. If a computer is listening for remote desktop, I use it for management. This will detect it and tell you. And in fact, it will even take a screenshot to show you exactly what you can see. So there you can see the desktop of my Windows Server 2003 computer, prompting the user to press Ctrl-Alt-Delete. So as you can see, Nessus did identify some serious vulnerabilities that I would want to address. And I'll jump over to the Vulnerabilities tab here. This is the same information, it's just sorted differently. Instead of looking at it on a computer-by-computer basis, here I'm just seeing all the most serious vulnerabilities on the network. And the way it works here is I can click on a particular vulnerability and it drills down into the data and tells me exactly which host has the vulnerability. You can see this is another router that has the default SNMP community name, something else that I should fix. So in summary, this type of vulnerability scan can reveal a great deal of information. It's much faster and more thorough than trying to do it yourself. It's also not as prone to human error. There are lots of different vulnerability scanners out there. Nessus is a popular one, and like I said, it was free for home use, so it's a good one to play around with and get familiar. So check it out on your own home, but then also get permission from your employer and use it as part of a full scan. And finally, we're on to step 6, the report and the briefing. Now, this isn't going to be on your SSCP certification exam. This is just from me to you, just some guidance and advice from my many years of doing this kind of thing. Now, you're going to be reporting your findings to the management, and this can be a very emotional time for people. People are going to be offended. They're going to be trying to blame other people because you're going to be finding vulnerabilities. And some people are going to feel like they have made mistakes. I can't tell you how many different systems engineers and systems administrators, database guys, they think they are perfect at security. They just think they're good at security, and therefore their stuff has no security vulnerabilities. It's never true. You always find some vulnerabilities, some oversights, some mistakes. That's why this whole process exists. If that wasn't the case, you wouldn't be doing this. So let them know that you're their friend. You got their back. You're just making sure everything's good. None of it's a surprise to you. None of it's bad. In fact, it's good. You found it before the bad guys did, right? We're going to focus on the positive. We're going to focus on fixing things, implementing things, learning from oversights and mistakes. As with any presentation you have to give, make your reports pretty. If you can throw in colors and bar charts, that's a lot more appealing than just long lists of data. Also try to just be as brief as you possibly can. I guess you guys already know some of my philosophies about presentations because you've been watching them a lot. But I try to put as many visuals in as possible. I try to be as brief as possible, and I try to provide the highest level of information I can while satisfying the needs and curiosity of people. I know a lot of technical guys have a tendency to dig way too deep into the nitty-gritty of it. So speak to the highest level person there. If the CEO is in the room, then you need to be given a CEO level presentation and let other people drill into more detail as they see fit. Otherwise, you're going to lose their attention and they're going to be bored. And finally, there's going to be finger pointing. Maybe it doesn't happen in your meeting, maybe it happens later, but it's not going to be coming from you, right? Because you don't blame anybody. You don't know who was supposed to do what. It's not your scope at all. You're just checking things out and reporting the findings. And what now? Well, you're going to decide to accept some of the risks, a lot of the risks. If you have a web server, well, that's a risk, but you're going to want to accept it. Somebody could attack it. It's a vulnerability, it's an asset, and there are legitimate threats out there, but you need it, so you just accept it. Risks that you decide are unacceptable, you mitigate them as best as you can. These mitigations are often not absolute. You don't eliminate the risk, but you can put a firewall in front of your web server and reduce the risk. Now that you've done your reports, you have the baseline, and you just need to monitor for changes. Anytime somebody plugs in a new computer, somebody needs to assess the risk of that new computer. And of course, when you repeat this process, you should do it on a regular basis. It's not going to be nearly as hard because you'll already know so many different things that are just completely false alarms or risks that have already been accepted, and you don't need to report on those again. In the future, you'll only be reporting on those things that have changed. So your reporting and scanning will be much easier. This is Tony Northrup for Train Signal, and thanks so much for watching this video lesson.